Hi, and welcome to 6.1 example 1a. Here we want to graph the solution set for the inequality x minus 3y is greater than or equal to 6. And if we look at this here, we can see that they both belong to the real number set. X and y are real numbers, which means the number sets that contain fractions, decimals, everything. So it's not just answers like 1. It includes things like 0.5, 0.2, and so forth. So our x and y values can be any of those. Okay, and another thing to note is that in our question we have a greater than or equal to sign, which indicates that the points on that line that we're going to draw will also be in our solution set. So what we want to do here essentially is to graph the line x minus 3y equals 6. Okay, so we need to graph that line first. So we need to just forget about the inequality part and just do the equals part first. So to do this, we can graph it a number of ways. Some different ways are a table of values, x and y intercepts, or slope-intercept form. Probably what you want to use is slope-intercept form. So that's what we usually refer to as this y equals mx plus b. So to get this equation into y equals mx plus b, we need to get the y by itself. So the first thing I do is subtract the x to the other side of the equal sign. Next thing I do is divide out that negative 3, and remember to do that to all the terms, so we get y equals 1/3 x minus 2. So that became positive 1/3 because we had a negative divided by a negative. Okay, so now we have the information to graph this line. So remember that the 1/3 is our m value, or our slope value. The negative 2 is our b value, or our y-intercept. So before we can graph this, we need to go over to our graph and label our axes and label our scale. So we have our x-axis, our y-axis, and with our scale, just looking at the values we're working with, we've got like 1/3 and negative 2. So that means we can just make each of these boxes 1 and that will be good. So we'll just label a few of those. Make sure you label some so it's clear what your scale actually is. Okay, so we've got some of those labeled. Now to put this information from the equation onto the graph. Right, so the y-intercept is negative 2. That's what we start with. We put the y-intercept of negative 2. Now the next thing we do is deal with our slope. So our slope is 1/3. Right, what does that mean? Well, that means we have a rise of 1 and we've got a run of 3. So we go to our point, the y-intercept of negative 2. So we always start at the y-intercept, and to find another point on this line we go up 1 over 3. Okay, so there's another point on our line. And we can go up 1 and over 3. We get another point on our line. We go up 1 over 3 and get a fourth point on our line. So we can do that as many times as we want in order to get enough points for that line. So again, since this is a greater than or equal to, we will draw a solid line through those points. So you take a ruler and draw a line through all of those points. Okay, and extend it all the way across your graph. Okay, and then remember to put arrowheads on the end of your line. And now we have the line y equals 1/3 x minus 2 graphed, which this line also is our original equation that x minus 3y equals 6. But remember, our original equation wasn't actually an equation, it was an inequality. So instead of it being equals 6, right, it was greater than or equal to 6. So how do we figure out what to do with that? So essentially what we're looking to do is we want to know, is our graph this whole area down here, or is it this whole area up here? So there's a few ways of figuring that out. One way that I'll recommend doing is to use what's called a test point. Okay, so to use a test point, you just pick a point on either side of the line. So generally, if you can pick the point 0, 0, pick 0, 0 because that's the easiest. So we take that point there, which is 0, 0, and we'll use that as our test point. And what we do is we put that into our original inequality. So our x value, based on this test point, is 0. Then take away 3 times by the y value, which is 0. And then we want to know, is that greater than or equal to 6? So again, is 0 greater than or equal to 6? No, 0 is not greater than or equal to 6. So that tells us that this side of the line up here that our test point is in is not our solution set. Okay, so that's not our solution set. So that means the area below the line is our solution set. So what we can do is we can put arrows on that line indicating that everything below it is our solution set, or a better way to do it would be to shade in the whole area below the line. Okay, and that's the actual answer to our question. The question asks us to graph the solution set. Our solution set is this entire yellow area plus the actual line, because it's a solid line.